Here's an example of a triangle, and what we are asked to do with this is determine what type of triangle is shown and then solve the triangle. Round angle measures to the nearest degree and side lengths to 1 decimal place. Okay, so look at what you're given here. How many side lengths are given? How many angle measures are given? And what's the relationship between the side lengths and the angle measures that are given? In this case, we're given 2 angle measures and a non-included side. And so we would consider this an angle-angle side case, which is a prime candidate for the law of sines. So let's go ahead and solve the triangle. Take a second and organize your work by determining what you know and what is needed. Make a little table and organize what you have. And then look at what you have and decide, well, what's the best thing to do first? And if I'm looking at what I have, I know I've got 2 angle measures. So first thing I'm going to do is use the triangle sum theorem to find the measure of angle A. That's an easy one, right? Because the 3 interior angles of any triangle should sum together to equal 180 degrees. So I can set that up. Measure of angle A plus 35 degrees plus 105 degrees is equal to 180 degrees. And so the measure of angle A will become 40 degrees. So I'll go ahead and put that in my table. Now, the next thing I want to do is set a proportion using the law of sines that facilitates finding the remaining side lengths. Okay, so what was the law of sines again? The length of side A over the sine of angle A is equal to the length of side B over the sine of angle B, which is also equal to the length of side C over the sine of angle C. Okay, that's great. Now let's sub in everything we know. I know that B is going to be 7. I know that angle A is 40 degrees, angle B is 35 degrees, and angle C is 105 degrees. Okay, so there we go, just like magic. Now I have a proportion that will allow me to find the length of side A and the length of side C. Now we're going to focus on a part of the proportion at a time. We're going to focus on this part first, because with this part I can just focus on these 2 ratios that are equal to each other. And I'm going to cross multiply. I'm going to say side length A times the sine of 35 degrees is equal to 7 times the sine of 40 degrees. And then I'll isolate A by dividing both sides through by the sine of 35 degrees. And then I'll get an approximation for this value from my calculator, and it ends up to be about 7.845, which means that the length of side A will be about 7.8 feet when I round to 1 decimal place. That wasn't too bad. All right, let's look at the other one then. Let's focus on these 2 together now. Okay, so let's cross multiply again. C times the sine of 35 degrees should equal 7 times the sine of 105 degrees. Okay, and so now if I want to isolate C, I'll again divide everything through by the sine of 35 degrees and get that approximation from my calculator. Now C is about 11.788, which means I will say it's 11.8 feet. When you solve a triangle, one thing that is good to remember is the smallest angle measure will always be opposite the shortest side length. The smallest angle measure is measure of angle B, and the shortest side length is also side B. That's true for large angle measures as well. Here's the largest angle measure, 105 degrees, and the longest side length. So here's another example. Here is another oblique triangle, and we are going to do the exact same thing with it. We are going to determine what kind of triangle this is. I have 2 angle measures and the side length between them, so this is an angle side angle triangle. Another great candidate for the law of sines. So let's organize our work. fill in our table with what we know and what we need. What do you think we're going to solve for first this time? If you said the measure of angle C, you would be right. I have two angle measures, so it's easy to find the third one by using that triangle sum theorem. Okay, so 76 degrees plus 34 degrees plus the measure of angle C is equal to 180 degrees. And so that means the measure of angle C will be 70 degrees. So now, what do you think we'll do next? How are we going to find those missing side lengths? Well, if you said use that law of sines to set up a proportion, you'd be right there too. Okay, so again, here is our law of sines. Now, what is the pair that has the angle measure and the side length given? Notice that that is our C. And so I'm going to place this right in the middle instead of putting C on the outside, just so it's easy for me to grab the appropriate proportions. So instead of doing ABC, I'm going to do side length C over the sine of angle C in the middle, and side length B over the sine of angle B on the end. Okay, and so that will look like this. Side length A over the sine of 76 degrees, side length C, 9 over the sine of angle C, which is 70 degrees, and side length B, which I don't know, over the sine of 34 degrees. So again, let's go ahead and focus on one piece at a time. So this proportion will give us, when I cross multiply, A times the sine of 70 degrees is equal to 9 times the sine of 76 degrees. Divide through by the sine of 70 degrees and get an approximation from our calculator. We should get about 9.3 here. Okay, and we'll put that in our table, and we'll do the same thing for the other piece. B times the sine of 70 degrees is equal to 9 times the sine of 34 degrees. Divide that through by sine of 70 degrees and get an approximation from our calculator. Okay, so let's just do a spot check. Which is my largest angle here? That would be angle A. Now, is side A the longest side? Well, yes it is. Which is the smallest angle measure? That's measure of angle B. Does that correspond to the shortest side length? And yes, indeed it does. Just a good spot check there. And that will wrap up our first video in the law of sines. In our next video, we will talk about our third class of triangles that we could potentially use law of sines with, and that is the SSA triangle. I will see you then.